Let's talk about percent composition problems and look at how to solve the two kinds of percent composition problems that we see in basic chemistry. Getting the chemical formula and finding the percent composition of each element, and then getting the percent composition from laboratory data. Both of these are really quite simple. Let's recall that chemical formulas are derived from lab data, and we'll see how to find empirical formulas from laboratory data in another one of these videos. Chemical formulas tell us how many moles of each element are found in each mole of a compound. In ionic compounds, there are no molecules. But for instance, in sodium chloride, we find 1 mole of sodium for every mole of chloride. Therefore, in our formula, NaCl, we imply a 1 subscript behind each of the elements. So there's 1 mole of sodium for 1 mole of chloride. In magnesium nitrate, there are 2 moles of nitrate for every mole of magnesium. That's why we have a 2 outside the parentheses around the nitrate ion after an implied 1 with the magnesium ion. Molecular compounds are made of discrete molecules, discrete packages called molecules. The formula actually tells us how many atoms of each element are in 1 molecule of the compound. As an example, P2O5 tells us that there are 2 atoms of phosphorus bonded in a complete package to every 5 atoms of oxygen. And actually the formula is P4O10, but we won't get into that here. The important thing is the ratio is 2 to 5 phosphorus to oxygen atoms. Now you already know how to write formulas from names, so here are the rules to write percent composition from chemical formulas. First, you write the chemical formula. Then you write down the masses and number of atoms that you see in the chemical formula. You add up all the atomic masses to get the molar mass, and you divide each of the atomic masses by that molar mass and multiply it by 100 to get the percent. Let's go for an example. The rules are listed on top. The percent composition of magnesium sulfate. Well, magnesium is +2 and sulfate is -2. Therefore, the formula is MgSO4, 1 magnesium to 1 sulfate. The masses are, magnesium is 24 and there's 1 of those. Sulfur is 32 and there's 1 of those. And there are 4 atoms of oxygen, therefore 4 times 16 grams per mole. The total molar mass, 120 grams. We then do for each of the 3 elements the calculation above. We divide 24 by 120 to get the magnesium percent, which is 20%. We divide 32 by 120 to get the percent of sulfur, 26.7%. And we divide 64 grams by 120 to get the oxygen, 53.3%. And they should add up to 100%. Now your turn. I'm going to give you 1, 2, 3, 4 compounds. You write the chemical formula, write down the masses and number of atoms, add up the atomic masses to get the molar mass, and divide each atomic mass by that molar mass and multiply by 100. Turn the video off and then come back to find the answers. There are the answers as I have worked them out, and I hope that corresponds with what you have. Now, to get the percent composition from lab data, you will find the mass of each element from what you write down in the lab, and of the total compound, the amount that you start with, and then divide each mass by the total and multiply by 100. So this is even easier than using the formula. So for example, If we electrolyze sodium bromide salt, we produce 4.6 grams of sodium metal and 16 grams of bromine gas. So what is the percent composition of sodium and bromine? Well, the total, of course, is 4.6 grams from the sodium plus 16 grams from the bromine, or 20.6 grams. We take the percent composition of sodium by dividing the sodium mass by the total and multiplying by 100 and getting 22%. The percent composition of bromine, we divide 16 by 20.6, multiply by 100, we get 78%. Now your turn. 8.3 grams of potassium oxalate contains 3.9 grams of potassium, 1.2 grams of carbon, 3.2 grams of oxygen. What's the percent composition of each? Work this out using the rules and then come back and turn the video back on to find your answer. There's the potassium, 47%, the carbon, 14%, the oxygen, 39%. It helps to check your work. We add up all of these fractions to get 1.00 or 100%, and that means that our answer is reasonable.